this video, we're going to talk about reactions of amino acids and their exam-style questions. A video in which you can stop and do the question and then see the explained answer. So first of all, we're going to look at esterification and addition of an acid to an amino acid, which is a very, very common question in your exams. So the amino acid we're going to use is tyrosine, and that's shown here. And you can see that it has lots of different functional groups. It's got a phenol, it's got an amine, and it's got a carboxylic acid. Now, we want to know what happens if you add hydrochloric acid to it, and we want to know what happens if you add alcohol and sulfuric acid and reflux to it. Hopefully you should recognise that this one will be acid plus a base, and this one will be esterification. So let's make some space and start drawing our different products. So what you have to do is you have to look and see, where does this HCl react? This HCl is not going to react with an acid here, okay? Phenol is also slightly acidic, it's a weak acid, so it's not going to react with there either, but NH2 here is a base. And I don't know if you remember this, but you remember that this has a lone pair of electrons. And because it has a lone pair of electrons, that part is basic, okay? So a base will react with that acid. So if we just start to draw this all out, and remember that you can draw benzene with a circle just as much with these three different double bonds. Okay, we've drawn our phenol section. We then go down and draw our chain and go up to our carboxylic acid. And they're the two parts of the structure that you know it's not going to react with. So the acid is not going to react with the carboxylic acid or the phenol, both slightly, both acidic. We then go to our NH2. We know that's a base, and we know that this is HCl is a proton donor. The proton donor donates its proton to the N, and the lone pair of electrons forms a dative covalent bond with the H. So that basically means that we have N with another H added on. So this NH3 has taken that proton and made it there. Now that would be 1 mark, but to do it properly, and it's really important, if the acid has Cl there, it's still got Cl that reacts with it. And the Cl, if the H is plus, the Cl is minus, so you make a salt there. The really important thing is that this is an ionic bond, and as I've said in other videos, if you've got an ionic bond, that means that the melting point will be higher. Okay, and that's really important because these ionic bonds are a bit stronger. So we have our product there for the addition of acid to the base. Now let's have a look at what happens with the alcohol. Now the alcohol will react with a carboxylic acid, an acyl chloride, an acid anhydride. So any one of those three, because this is esterification. So the alcohol reacting with this acid catalyst at reflux. So we just need to look at whether we have a carboxylic acid, acid anhydride, or acyl chloride. Well, we have a carboxylic acid there. So that's where we think it's going to react. So all we do is as we did before, draw our phenol. There we go. And then basically we go along the chain, and there is our NH2. We'll come back to that in a second. Okay, and then we have here with our carboxylic acid, but our carboxylic acid is going to react with our alcohol. Okay, as well as that, there's going to be, it's a condensation reaction, so you lose H2O. However, this is an important thing, okay, if you lose H2O, it's a condensation reaction, remember, and there's an extra complication. The extra complication is you're adding acid to this. So if you're adding acid to this, again, you've got this lone pair of electrons. So the easiest mistake is to copy out and go NH2, but I'm not going to make that mistake, because if that is the case, okay, you can then say, right, okay, this is actually NH3 plus. And that is going to accept that proton. If it, because you've got that acid there, which is H2SO4. And so it's not going to be quite a simple here. Now, if you're doing it absolutely properly, then you would finish that off with HSO4 minus, okay? And that's because you've got this sulfuric acid and this alcohol, okay? And the sulfuric acid makes it a bit more complicated down here, and then the CH3OH makes the ester that is here. And they're often going to put these really complicated kind of questions here where they're just expecting you just to miss off that tiny little detail here. Now often what they'll do is not put it as H2SO4 here and just put it as H+. And if they put it as H+, you just put an extra H on there and that's it. You're done. Our next question is when you determine the molar mass of an amino acid and then use that to suggest the structure of an alkyl containing group, which is an R group. Okay, so this is very, very common again, and so well worth practicing. So the unknown compound, alpha amino acid, okay, with a branched R group. So it tells you that's telling you it's an alkyl group, okay, but it's got some branches coming off it. Gives you the number of moles, gives you the mass, okay, which means you can use that to calculate the molar mass or molecular mass. Determine that of the alpha amino acid, suggest its structure. Let's put this over to the side and let's start working out. So we have bits of information. We have the mole and we have the mass here. That means if you take the equation mole equals mass over mR and you rearrange that to equal excuse me, mR equals mass over mole. Okay, so we've rearranged it. We're now going to work out, and we've got our mass and our mole. So let's put our mass and our mole in. So our mole is 0.1542 and our mass is 20.2. So 20.2, okay, grams, which is going to be equal to 0.1542 mole. Okay, so we've got that. Now that equals 131 approximately. It's actually 130.998, but we're going to round it up to 131 because we're just doing molecular mass. Okay, and we're using that to work out the structure. So we've got that. We know we've got a molecular mass of 131. The important thing then is to look at the alpha amino acid. So if we go for the alpha amino acid, we can say that an alpha amino acid is going to be NH2, CH, R, COOH. So here's the really, really important thing. Okay, the important thing is that I want to know what the R is. Because I want to know what the R is, okay, if I can find out what the molecular mass of that bit and that section is, okay, whatever remains will be the molecular mass of the R. So what I can do is I can just work that out. So that means NH2, CH, okay, COOH. If you put it into a calculator, which hopefully you are doing it now, okay, remember you can pause this, okay, is going to be equal to 74. So we've got 70, so that's 74. We know the total is 131. So what we can do is we can do the calculation, just say 131 minus 74, okay. When you minus that 74 from that, you're going to get 57. Now I'm going to teach you a very simple exam trick now. And that simple exam trick is to say, right, okay, if you know you've got an alkyl group and you want to roughly know how many carbons there are, you can obviously divide it by 12 and things like that, but sometimes that's a bit misleading. So if you think about it, all alkyl chains are mainly made of CH2s. They might have CH3s, they might have the odd CH, but they're mainly CH2s. So if I look at CH2 and I just say, right, okay, CH2, if you add up the different atomic masses, is 14. So if I divide that by 14, it roughly comes out, let's say roughly, okay, so it roughly comes out as 4. Okay, so roughly comes out 4. That means there is going to be 4 carbons in our chain. So that's 4 carbons in our chain. So we can start then playing around with structures. So let's start playing around with our structures. We can do it skeletally or structurally. I'm going to do both. And we can even do displayed. So if we're looking at, first of all, skeletal, here is our NH2. There's our alpha amino acid. Okay, there's our COOH. Okay, we need to know the R group that's coming up off here. Okay, there's our R group. There's our R group down here. We want to know what's coming up off here. So we've got 4 carbons. Let's think, what can we do with 4 carbons? Or what we can do, well, let's make it, it's got to be branched, so let's make it 3 carbons long. First of all, and there's your 3. 1, 2, 3. Got to make it branched. So let's put a branch on there. So if the question is asking to suggest the structure, you've suggested the structure. But sometimes the question asks you to state what the R group is. So the R group is going to be equal to this section here. So we start off with CH, which is this one here, to a CH3. The CH3 is coming off the CH. Okay, then a CH2. And then the final one is a CH3. So if you're asked to suggest the R group, there you go. If you're asked to suggest the structure, here you go. Okay. Now, if you want to do this in displayed, you can, but it takes a lot longer. Okay, and if you're not sure about it, do it in displayed though. Okay. Now, that's not the only answer. Okay, there are different answers here because we've got 4 different carbons to play with. So we could actually do the following. We could put our NH2 on again. Let's put our simply at COOH just for simplicity. Okay, and then put our 3 carbons off again. Instead of putting the methyl on the second one, we could put the methyl there. Okay, and that means our R is this time going to be CH2, then CH, and then 2 CH3s. Okay, now I've shortened the COOH down a little bit here just for space, but if you're going to do this fully in skeletal formula, I'll do it in fully skeletal formula in the last example because that's probably the best way of doing it. So we then go to our final one. Our final one is going to be NH2, and there's our skeletal formula. If you want to do it fully in skeletal formula, that's how you should do it. But again, I did that just for space-wise. And then your last example here, we could put 2 carbons on and then 2 branches like that. And that would mean that your R group is going to be C with 2 CH3, sorry, not 2, 3 CH3s on. So 1, 2, 3, 3 CH3s. So we have a question that's asking you to suggest a structure. If you suggested that structure, okay, that structure, or that structure, it would all be correct. But there's some really simple things here. First of all, work out your molecular mass, your molar mass at the top, minus away whatever's left of your amino acid, which again is this bit here. Okay, once you've taken that away, do a simple calculation divided by 14. It roughly gives you how many carbons you've got. You know, therefore, you've got 4 carbons. And then just play around with the isomers of 4 carbons, like I've done here, here, and over here. And you'll be able to suggest your structure and be very successful with this type of question. We move on to our final exam question, which is a reaction of an amino acid with a base. Okay, so again, very, very common. The general formula is given to you in the question, then the alpha amino acid, glutamic acid. Now, the real common thing about this is that they don't draw the amino acid, they just give you an R group and expect you to attach that R group onto your alpha amino acid base. Okay, and then we draw the structure of the salt forms. They give you, they want you to draw the salt, and they include either hydroxide or sodium hydroxide. Let's move this over to the side. Now, if we start drawing this out, we have to be able to draw the amino acid from that general formula that we've now highlighted over there. Okay, now general formula can be put in many different ways, but essentially what's really important is that you can look at it and transfer it. So for this one, just draw it in displayed formula. So you've got the C at the start, you've got an NH2 coming off the C. Okay, so you've got an NH2 coming off the C. Okay, and then it says you've got the R group coming off the C, so let's put the R group off the C. So it's a CH2, so there we go, 2 Cs. There's our CH2s. Okay, and then we've got a COH, so there you go. And there's our OH. We've drawn most of it. Okay, that's our R group. Remember, we're still on our general formula, so it says RC. R is on the C, so that's our R, and it says that there is a H on the C. Okay, and remember, so we've drawn our R so far. We've drawn the CH, which is that CH here. And we've drawn the NH2. Now we've got to draw the COH to finish off. So here's the COOH. Now, if we're doing full displayed formula, we really would have to put the bond in between there as well. Okay. Now, that's a full displayed formula of it. The alpha amino acid glutamic reacts with an excess of the sodium hydroxide. So we have got to have sodium hydroxide. Now, the important thing is the sodium hydroxide has an Na plus and an OH minus. The OH minus is going to react, it's basic, essentially, it's going to react with any acid. So you have got an acid right here, you've got an acid right here. So this OH is going to react with both that acid. That's the really important thing. And it's going to deprotonate it. So basically the OH is going to react with that H and react with that H. And you should get, for example, 2 waters as the product. But they're only asking you to draw the structure of the salt, but you should get 2 waters. Now if we do that, that means that that H will be gone, and that H will be gone. Okay. So with the H gone, you've got the O's behind there, and the O's are negative because the H pluses have gone and donated. That means the NAs are positive, and they're going to bond with the Na plus. Now, really important thing is here, you've got to look out elsewhere. Is there anything else? So the acids have reacted with the base. Acids have reacted with the base to form this carboxylate salt. Is there anything else? Well, the NH2 is not going to react with the base. You can also do the following. So if you want to get this, if you want to do this in a slightly different way, you can get rid of the pluses, get rid of the minus. And it could just be an A. You can do it like that if you want. Doesn't really matter whether you've got the pluses showing and the minus is showing, but again, recognise that is an ionic bond, and therefore the melting point of this is going to be generally higher than other things with the same molecular mass. This is very, very common, okay, and they can do the opposite with an acid. So, for example, put an extra NH2 in here and have an acid. So don't just look for the NH2 that's there, look for the NH2. So look at all functionality within the amino acid. We've gone over 3 of the most common exam style questions that are associated with amino acids, and hopefully you've gained a lot of information from the 2 videos on this subject. Now is the time to do the worksheet that is attached to this video so you can further embed and practice those skills.